All right, so again, we didn't have class on Friday. I made that recording. I would love to ask how many people accessed the recording and started doing the work in lesson 14. If you have, that is so awesome. If you haven't, well, it's a good thing you have a long weekend this weekend with which to do it. So my assignment to everybody for the missed class was that I made a recording for lesson 14. I had sent the entire class an email with a link to that video and to the notes. So my hope is that you watched it, and I'm certainly happy to answer any questions. Just to kind of put us back on the same page, since it feels like ages since we've had class, and that's just going to happen again very shortly because we only have 2 days of class this week. What I want to say is as follows. I'm going to share my screen. In terms of upcoming assignments, lesson 12 is due tonight by midnight. Lesson 13, which we finished last week, is due this Wednesday by midnight. And finally, lesson 14, which is that short assignment that I did, is not due until a week from tomorrow at midnight. I wanted to have you have an opportunity to ask questions. My hope is that you finish it well beforehand. That would be in your best interest. The other thing that I'll remind you of is in that lesson 14 video, you'll see that I go through each homework question at the end and kind of outline exactly what it is you need to do. So it would very much be in your best interest to watch that lesson 14 video. Plus, it's pretty short, relatively speaking, in terms of a class video. So I certainly recommend that everybody access that. The other assignment that I gave, which is due Monday after Thanksgiving, so due a week from today, is that worksheet on Moodle, class activity 7 and 8. It is on the Moodle page under the class activities. Those of you who are here today in class, I have printed copies if you want a printed copy. Other thing for those of you in class today who may not have been here, I have your exams. I love to hand papers back. So it sure would be nice to give those tests back to you as well. I think that does it for reminding everybody where we're at. What we have left, just as an overview, is we have class today and tomorrow. And then we're off for the rest of the week. We'll be back a week from today. And then what we have are 2 full weeks of classes and then finals. So we're getting real close. What I'm going to say in terms of online homework is, and sections, is we have 3 sections left. We have lesson 15, 16, and 17. Okay, lesson 15 is 1 homework assignment. Lesson 16 and 17 I combined together as 1 homework assignment. Okay, so we still have lesson 12, 13, and 14 open to do, but technically we've covered all that, so we really only have 2 more homework assignments yet for me to open. Also, the Monday after Thanksgiving, I will hand out worksheet 9, 10, which is then the last set of in-class worksheets. Okay, so we're kind of getting close. So please be sure that you are caught up on on all of the due dates. Are there any questions about that? Just like practical stuff. All right. Okay, so I got a request to do one more example out of lesson 12. And so I want to go in and do that prior. And then if there's any other questions over lesson 12, 13, 14 online homework, I'm happy to answer any and all of those questions as well. If there are not questions past this one, I'm going to just jump into lesson 15. But please know that I'm happy to answer questions first thing tomorrow as well. Okay? So I can't remember what question number this is from lesson 12, but I'm going to do it anyway. So suppose we have this equation. Ooh, I don't remember the ordered pair. Do you? Okay, hold on one second, folks. I guess it doesn't matter. Yeah, okay. Okay, so suppose I have this line. Suppose I want to find the equation of the line parallel to the above. Passing through, oh, who cares? 10, -3. And then what I want to do is find the equation of the line perpendicular to the above, passing through that same ordered pair. Cool? All right. Well, what do we know about parallel lines? They have the same slope. That is the key. Okay. So given the fact that the line we're looking for is parallel to this line, we know it has the same slope. Therefore, we already have this much of our equation of the line. What we need to find now is the value of B. Okay, we have the M. So how can we find the value of B? Not a rhetorical question. Plug in this ordered pair. I know Y is equal to -3 when X is equal to 10. So, well, I mean, you can multiply across, you can use fractions, however you want to solve it, but we're going to have -3 is equal to -4 plus B, right? 5 goes into 10 twice. -2 times 2 is -4. And then to solve for B, we're going to add 4 to both sides. So we're going to get B is 1. So the parallel line passing through that point is -2/5 X plus 1. You with me there? Cool. On the other hand, if it's perpendicular, how do you find the slope of a line that's perpendicular? Good, we change the sign and flip it. So if the slope of this is -2/5, what is the slope of the line that we're looking for? Well, change the sign means it becomes positive, and flip it means it's, instead of 2/5, it's 5/2. So here, in terms of finding the equation of the line, we already have this. Again, what you do is you change the sign and you flip it. And again, the way we're going to find our value of B is to plug in our ordered pair. So again, I'll plug in that y is -3 when x is 10. Well, 2 goes into 10 5 times, so we have 25 plus b. We subtract 25 from both sides, so we're going to get b is -28. Does that make sense? Now, in the second part of that problem, you were either given the equation of a horizontal line or a vertical line, and you were asked to find a parallel and perpendicular one to that. Do you want me to go through that as well? Okay, so suppose I have the line y equals -16. And I want to find the equation of the line parallel to it that passes through, I don't know, 11/21. It's November 21st. That's just how original I am today. Well, we know whenever we have a line of the form y equals and there's no mention of x, that it's a horizontal line. Okay, this is an important thing to track. And it's something you have to memorize because you get notes with your work. But what type of line is parallel to a horizontal line? Isn't it another horizontal line? And we know the equation of any horizontal line is y equals whatever the y value is. Well, what is the y value this goes through? 21. So it's y equals 21. Oh, I was going to write perpendicular to it, and then I started writing it as one word. So perpendicular to it, passing through the same ordered pair. Well, if this is a horizontal line, what type of line is perpendicular to a horizontal line? A vertical line. And we know the equation of any vertical line is x equals whatever the x value is. So if it passes through this ordered pair, what is the equation of this vertical line? X equals 11. Are there any other online homework questions in lesson 12, 13, and 14? Number 5 on lesson 13. Anything else? Thanks, Riley. I love how you always ask questions. I think it's just awesome. And the whole class loves it. All right, nothing else at this point. Then I will do this one. If you have questions that come up between today and tomorrow, my goodness, ask me. All right, so I'm going to share my screen just to bebop over to lesson 13. Now, mine might look slightly different than yours, but it's all about the vibe. Okay. Okay. So here we have this graph. This shows the graph of the cost function and the revenue function. Okay. Now I want to talk about this for a moment before I jump in to answer whatever the question they ask me is. Okay, one of these is the cost and one of these is the revenue. Okay, we got to think about how our cost function and our revenue function are defined. Okay, remember our cost function has the marginal cost, in other words, the cost to produce each item, along with the fixed costs. In other words, when we produce no items, there still is a cost, right? Remember, that's like rent and health insurance for your employees and, you know, electricity and all of those fun things, okay? With our revenue function, if we don't sell any items, we don't make any money. Okay. So what I want to point out is the reason why I went through that is that tells me that my blue line is my revenue function. And my red line is my cost function, right? Because if I let X represent the number of items produced and sold, if I don't sell any items, my revenue is going to be nothing. But if I don't sell any items, I'm still going to have a fixed cost. Remember, our fixed cost is our y-intercept. So having said that, they want to know what the break-even point is. Remember, the break-even point is where your profit is zero. You don't make anything, nor do you lose anything. But the key thing is, given the fact that my profit is equal to my revenue minus my cost, if that's equal to zero, that means that my revenue and my cost must be the same. Okay, well, where are our revenue and cost the same? Precisely where my lines intersect. So in my particular case, my lines intersect here at 15,70. So that's exactly what they want you to note here. Okay. Next, they want to know, they want to know the fixed costs. Well, the fixed costs, remember, are your y-intercept for your cost function. So what are my fixed costs here? $40. Again, because that's my y-intercept. Riley, is that helpful for you? Awesome. No, thank you for asking. Are there any other questions? And I'm sorry about these lines that keep coming across this screen. I'm trying my best to make my cords happy here. All right. Well, Riley, you have no idea how awesome your question was, just in terms of a nice segue into what we're doing today. Did you miss class on Friday? Or were you all pretty psyched to have a 10 o'clock free?
Yeah.
Cool. Oh, I had class on Wednesday, didn't I? Yeah, it was a recording. All right. So this section, when I first started teaching over 30 years ago, it used to be a pretty involved section to teach, precisely because we didn't have technology that did the computations for us. So kind of like with our normal distribution and our binomial distribution, we ended up having a calculator that did all the background computations for us, and that's really sweet. Okay. Well, it used to be the fact that these our calculators did not compute matrices for us. And because of that, I would have to go through and teach you all about matrices and give you the whole background scoop about how to do computations with matrices and finding inverses and multiplying them. I think it's pretty cute, but most people are like, okay, so, well, anyway, fast forward to 2022, our calculators do the matrix computations for us. Okay, so what I will venture to say is that the second part of this section, what it's going to be is a lot of calculator. Okay, so there's three main things in this section. One, you are going to have to learn how to solve a system of two equations and two unknowns by hand. You can check it with your calculator. Number two, there's going to be some word problems. We're going to start honing in on how to translate them. Okay, don't worry. I'm going to do a ton of examples. Okay. And then number three, I'm going to teach you how to push buttons on your calculators so that you can compute matrices without having to do any of it by hand. Okay. So what I like to do before I even start any of this is give you some background, like, okay, who cares? Okay. It's probably the way people feel about most of their math classes to begin with, right? Thank you for smiling about that. No, I love getting reactions. Okay, so frequently, we need to find a solution. XY that satisfies more than one equation at a time. More than. And when you're looking at more than one equation at a time, it's called a system. Okay, so what's an example of a system? Well, how about this? X plus Y equals 5 and X minus Y equals -1. I claim these are both equations of lines. They're not solved for Y. This is in that general form or standard form. Okay, but this is a system. Now, what does it mean that we want to find the solution? It means we want to find the ordered pair X and Y that satisfies both equations at the same time. Okay, now Riley, I mentioned that you gave me the perfect segue by asking number 5 in lesson 13. By looking at the graph, we were actually looking at a system and we found the ordered pair that satisfied both at the same time. That was where our lines intersected. Okay. Now, what I'm going to give you is a technique so that you can, by hand, solve a system of equations. Okay, when we have two equations and two unknowns. When it gets bigger than that, that's when we're going to jump to technology. Okay, now you can look at this and maybe play around and figure out what might work. I mean, I could say, well, 4 plus 1 equals 5. But does that X equals 4 and Y equals 1 work in my second equation? No, because 4 minus 1 is not equal to -1. So the trick is to find an ordered pair that fits in both of these equations at the same time. Well, I claim if you play around long enough, if you let X equals 2 and Y equals 3, that'll work. Okay, in other words, the ordered pair 2, 3. Do you agree 2 plus 3 equals 5? Deep question for a Monday morning. And 2 minus 3 is -1. Okay, so this is sweet. This worked. Okay, But this was an example that was probably short enough that we could eye it and, figure it out. The thing is, oftentimes we have fractions and decimals going on in here too. And then it's just not that obvious. Okay. And then another reasonable question to ask, I mean, if you have two parallel lines, is there ever an ordered pair that's going to work for both lines at the same time? No, there is no ordered pair that lives on both lines. Okay. So what I want to let you know is, in general, for two linear equations, there are three possibilities. One possibility is the lines intersect. Okay, and I claim this is the ordered pair that lives on both of these lines at the same time. In other words, if they intersect, there is one unique solution. If two lines are parallel, is there an ordered pair that lives on both of these lines at the same time? No. In that case, there is no solution. Textbooks tend to refer to this as an inconsistent system. And finally, another possibility, and you might ask, how in the heck can that happen, is if you have the same line. Well, if you have that's meant to be two separate words. If you have the same line, aren't there infinitely many ordered pairs that satisfy? Yes, so we say that there's infinitely many solutions. And we call this a dependent system. I'm not wanting you to be extraordinarily concerned about the terminology inconsistent and dependent. And some of you might be like, excuse me, Lauren, if you wrote the same line twice, don't you think I would notice that? And my answer is yes and no. You'll see. Okay. So what we do is we say, well, any one of these three possibilities can work. Number one, on a test, I'm going to tell you, I'm not going to ask you to solve it by hand unless there's just one unique solution. Okay. So that's just a giveaway for the test, just because I don't want you spinning your wheels in a timed circumstance. But what we do is, if we can solve it, we say if X, Y, that ordered pair, satisfies both equations at the same time, it is where the lines intersect. So where does this come up in real life? Well, as the question that Riley just asked, the break-even point, precisely where your cost is equal to your revenue. Other places that comes up in quote unquote real life, another place using business as our go-to is called our equilibrium point. And that's where your supply is equal to your demand. We're not going to be getting into supply and demand in this, but that is another place where, practically speaking, we're interested in that. All right, so there's several methods to doing this. In other words, to find that point, that it satisfies both equations. Okay, one of them can be done by graphing, right? You can graph both lines and look at where they intersect. That could be fine and dandy if they intersect at a really nice point, but sometimes lines intersect at like -0.23 and then 0.57, and there's really no good way to eyeball that. Another method is called substitution. I like this method just fine, but it really works best in certain carefully curated examples. Another method that your book refers to a fair amount, and even if your online homework asks you to solve it using the echelon method, don't. Don't you love how I tell you don't follow instructions? Little do you know that this is Lauren Fern's nature. Anyway, total side note. The echelon method is the one that they might mention. This involves matrices. Please don't work that hard, okay? And plus you're gonna have technology in the background. The method that I'm going to show you is what we call the addition elimination method. I prefer this method because I think it works best in the most general of circumstances. Now, just like I'm not one to always follow instructions, perhaps, I'm also not one who likes to tell people how to do things. If you like using the substitution method, go for it. I'm not going to stand in your way. All right. But this is the method that I'm going to show you here in class. So what I'm going to do right now is write out the general steps to using this addition elimination method. Okay. Might seem funky, but then what we're going to do today and tomorrow is go through numerous examples of this. Okay. So one of the things that I'm going to say to you is we thought that there were 3 possibilities that can happen. I'm going to show you what it looks like in each of these 3 possibilities. Okay. Like what happens when you try to solve something that has no solution? What happens when you try to solve something where there's infinitely many solutions? But again, I'm going to piggyback around and say on an exam, this is the situation you're going to be in. Okay, so first step is if this is not already done, what you want to do is write the linear equations in standard form. In other words, you want to have the X's and the Y's on one side and your number on the other side. The exact opposite form that's helpful when we're doing graphing. Okay, now I'm writing out these steps. You don't need to memorize them. Ideally, you're writing them down and then you'll have them in front of you. And as we go through example after example, you'll start seeing the pattern. Okay. Wait. All right. So next, and again, this is going to seem really funky until we work through examples, but trust me, you're going to get more than you need. So determine which variable you wish to eliminate. Eliminate. Okay. Notice that's where the elimination in the name comes from. Okay. Honestly, it doesn't matter which variable you choose to get rid of. My MO is to do the one that requires the least amount of work. Imagine that. Okay. Now, the way you do that is as follows. Multiply one or both equations by a non-zero constant, in other words, by some number, to get what we call additive inverses. In front of that variable. This is the biggie step. Now, again, this is going to seem rather vague until I actually talk about what the additive until we actually get to an example where we need this. But let me just say additive inverses. Not sure if you remember that, but 5 and -5 are additive inverses. 3 and -3. -17 and +17. Okay, any numbers that you can add together to get 0 are additive inverses of each other. Are there any questions on what additive inverses are? Okay, so it's a number and the opposite of it. All right, from there, what you can then do is add the equations and solve for the remaining variable. And I know this seems like a lot of steps, but I assure you, we're cool, we got this. And this is where the addition portion of the name comes from. And then last but not least, take that value found in step 3 and plug it in either one of the original equations to find the value of the other variable. Please have these steps in front of you as you're starting to work these examples, especially if it's the first time you've ever done these sorts of things. Now, we're not going to have time today to do very many, but we have tomorrow. Hooray. Y'all have no idea how much I miss teaching you on Friday. Just by the way, like I really missed it. My day on Friday started at 7:15 in the morning and I didn't get back to where we were staying until 10 o'clock at night. Yeah, so it's like, oh, no math. Okay, anyway, what's an example? Let me take this one. This is the one that we eyeballed. Let me show you how you would do this as a first step. I'm starting out with ones that don't require as much work because I think it's important that we build. Okay, so notice your first step is to write the equations in this form. We got it already. Number 2 is determine which variable you wish to eliminate. The key thing is additive inverses. And I claim we already have additive inverses in front of our y. Okay, what is the number in front of this y? Isn't it a positive 1? And the number in front of this y is a negative 1. Okay, so we already have additive inverses. We don't even have to do step 2. So I claim what we can do now is step 3. Add the equations together. What is x plus x? 2x. What is y plus negative y? They cancel. That was the point of the additive inverses because it would eliminate these guys. And what is 5 plus negative 1? 4. Well, I added the equations. Can I solve for the remaining variable? Heck yeah. How do I get x all by its lonesome? Divide both sides by 2. So don't I get x to be 2? 4 divided by 2 is 2. Now what step 4 says is take that value and plug it in either one of these original equations to find the other value. We have x, we need to find y. Doesn't matter which one because it's going to live on both of these lines. So I'll plug it in the top one for no good reason. If I found x to be 2, then I can say, well, 2 plus y equals 5. And I can solve for y by subtracting 2 from both sides. And lo and behold, I get that ordered pair 2, 3. Going to do one more short example for today. And then stay tuned for tomorrow where we dig in deeper. What if I have 4x plus y equals 9 and 3x minus y equals 5? This is another example where we don't need to do step 1 or step 2, okay? Clearly, I'm going to choose to get rid of my y's because it's not going to involve much work. Okay, right? I have a positive y and a negative y. They're additive inverses. So I'm going to add these up. What is 4x plus 3x? 7x. And what is 9 plus 5? 14. Can I solve this equation? Heck yeah, what do? Divide both sides by 7 and we get x to be 2. And no, x is not always 2. It's just the number for today, I suppose. Am I done? No, I need to find my corresponding value of y. So what do I do with this value of x? I plug it in either one of these two equations. Who do you want to plug it in, top or bottom? Bottom. Okay, I love when people have opinions. Okay, so if I plug it in the bottom one, I have 3 times 2 minus y equals 5. Do you agree that gives me 6 minus y equals 5? How would I get y alone? First, I'd subtract 6. So I have negative y is negative 1. But I don't want negative y, I want y. So what do? Multiply or divide both sides by negative 1. We're going to get 1. Now, the other totally cool thing about this is you don't even need me around to grade it. You can check your answer. How can you check your answer? Plug 2, 1 in both equations, and you better have equality. Do you agree if I plug in x equals 2 and y equals 1 here, I'm going to get 9? 4 times 2 is 8, plus 1 is 9. So tomorrow, what I'm going to do is I'm going to jump in and do ones where we actually have to get additive inverses. Cool? Awesome. Have a great day, my friends.